Friends, welcome to BISP Solutions. Myself Ashwin and I work as a technical consultant at BISP Solutions. BISP Solutions is a tech company that provides technological solutions across the world. Now in this video, actually this video is the part 2 of our previous video that we have discussed in day before yesterday. So now I recommend you to watch that video also so that you will get the complete picture exactly what we are going to do in this video. Now see here, in our last video, we discussed credit card default prediction. Let's have a quick recap on that. Uh, in this video, see the banks and the institutions that are giving loan to the people, they are also at high risk that whether if their credit card gets defaulted, in that case, how to recover that. So for this, they use some prediction techniques. Prediction technique means what are the chances that a credit card will get default. So they are having their historical data, right? So they are having the historical data, and with the help of that historical data, they predict, they analyze. Now to analyze the historical data, there are some certain criterias. So in this video also, I will show you the process. If you could not watch the last video, doesn't matter. I will explain you in this also. So see this. Credit card risk refers to the possibility of loss that a lender or the investor may face due to the failure of the borrower. Suppose if the person could not repay the EMI. So in that case, what will happen? So to prevent such type of situations, they use some prediction techniques. Some prediction techniques are used, and based on those techniques, we can easily identify, we can easily predict what are the chances, right? What are the chances of risks? So first of all, let me show you the data here. This is my NetSuite, and if I show you credit card customer record type, this is a custom record and credit card default. Here it is, customer credit card. Okay, so I have the complete list right here. Okay, so we are having the historical data of historical data of the customer, right? These are all the data, and I have stored it into my folder here somewhere, right? Here is UCI credit card. Okay, so now based on this, with the help of pandas, I will start working on it. Okay, so this is my fresh notebook. Okay, so I am going to start with this. Okay, so first of all, we have to import all the libraries. Okay, so let's import all the libraries. Import pandas. Pandas is a very important library, so we will use pandas as PD, then import numpy as np, import seaborn as sns, import matplotlib dot pyplot as plt. That's it. Hit the enter button. Okay, now we have to read the Excel sheet or the CSV, right? We have to read the CSV. Okay, so let's read the CSV also. Now just I have entered this, and now I will put this. Okay, so let hit the enter. Now see here. Now I have received all the data here. Now, right, this is the ID and this is the default status. Now this is the historical data based on which we are going to predict. Okay, so this is the historical data. Now what we need to do here. Okay, so not what we need to do here. Now let's get the info. Okay, first we will check if there are some missing data. Now see, df.info means we will check for some missing data. So here you can see non-null, non-null, non-null. That means everything, every data is filled. Now in that case, now see, ID is not required. You can see this, that ID is not required in this table, right? So what we will do here, we will just remove the ID, drop ID. Df.drop ID access 1 in place 2. Okay, so again I will, if I put here df and hit the enter, see here df is ID is removed. Okay, now df.columns. we have to get this df dot columns. Okay, df dot columns. These are the columns that we are having right now currently. Now, from these columns, we have to extract all the gender variables, right? Based on, look at this. Now, gender, df data x equal to gender and u equal to default state. Now, see here, ax dot sns, that is the seaborn, right? KDE plot and default df is the data frame, which is this data, and then x equal to gender. In place of x we put gender, and y level we will put default status, right? Now here you can see we are plotting an image, male 0. 0 means not default, 1 means default, right? So in this way, the percentage wise, if you see, the data is showing you, right? Now, next what happens, we will separate the data in the on the basis of education level. Now see, these are different criterias. For example, if a company of a car wants to open the showroom in a certain city, any city from India or any other country, so what type of criteria does the country will look after? First of all, company will see that in which city, in the city where we are going to open the showroom, how many population, how much population is there, then how many colleges are there, what are the living standard, how many shopping malls are there. So all these things defines the living standard of the people, then only they will open a car showroom, right? So similarly here also same thing. On the basis of gender we have separated value, on the basis of education variable, right? So all, now what happened here, we have taken here default education on the x level and default status, right? Now we have taken graduation, school, university, high school and other. These are the criteria on which distribute data is distributed. Education distribution according default, right? So these are the, that means default status 0 and 1. Based on this, that means those who are highly qualified from university, in there the the number of default status is less. Here this color, orange color, shows the default status, right? That means they are defaulting. So this is based on education level we have extracted the data. Now on the basis of married and single, right? On the basis of married and single, look at this. First, let me plot the image. Okay, now see how many are on the basis of married and placed, married and unmarried, right? So you can see here KDE plot data df, that means data is a variable and df is your data frame on the basis of x equal to marriage and y equal to default status, and the u equal to default status, and then plt dot x tick married, single and others. We have distributed in 3 parts. We have not taken the child count, right? Okay, so plt dot show means it is showing into a graph format, right? Now, what we will do next? We will do here, see. Now see here, age distribution on the basis of age. See, 0 and 1 default status, right? On the basis of age, we have distributed. Now, on the basis of age we have distributed. Now let me show you the df dot column dot columns. These are the columns. Okay, now what we need to do, create a target feature and independent feature. Now here we have to extract the data in the format of x and y. X equal to default status, x is 1, and y equal to default status, df default status. So x wants to drop this default status and y take that default status and put it into df, different separate frame, right? Now how it will be done, let's see this. Look at this. Now what will happen here, Now let's see this. Now we have to open the sklearn and xtrain and xtest. Okay, so xtrain and xtest, look at this. Sklearn model selection, import xtrain test split. See, we have to divide the data into training and testing. So 80% we keep for training purpose and 20% we keep for testing purpose. You can see here 20%, 20.20, that means 20%. So 20% is for testing purpose. So train test split. Train test split is a function, or we can say is a facility given by sklearn module, sklearn model. And then what we will do here, we will just train dot test, train underscore shape, xtrain shape, xtest shape, ytrain test shape, ytrain, ytest shape, and just enter. Okay, these are the number of rows, right? Now what next? Now we have to deploy the logistic regression. Okay, so logistic regression, just a second. Logistic regression comes here. Okay, now see here, logistic regression is applied, sklearn import matrix and all these things. And in this way you can see prediction login, prediction log it. Okay, now here if you see print, see here, this is the accuracy is 78%. Now it has shown that the if you apply logistic regression, the accuracy will be 78%. Now what about the decision tree classifier? So let's try that also. Decision tree. Now look at this. This is 81% accuracy. So in our next video, we will see forest prediction. Okay. In our next video, we will see the random forest. Okay. The random forest prediction. Okay. So now for this, what I have shown you. So for this, what I have shown you so far, the prediction of both. One is the logistic regression prediction. Here is the decision tree prediction. Here is 81%. That means it is more accurate. Okay. In our next video, I will show you about the forest prediction, right? And then we will compare all the three types of predictions, right? So guys, this is a little bit complex. So please practice it, and once you practice it again and again, it will become more easier to you, right? And if you are new to this channel, please subscribe my channel. So see you in our next video. Thank you. Thanks for watching the video. Thank you.